Welcome back. This video is going to cover how you create visual displays to show bivariate relationships. So how do I show the distribution of y given x, where y is numerical and x is categorical? So I'm going to remember I said there were three generations of graphics routines in R. There's kind of base R. Then there's the trellis lattice generation that we're not going to do much with in this class. And then the third generation is the Ggplot. So I'm going to show you both the base and the Ggplot. What you're going to see is that with some of these, it's really easy to do in base. Takes a lot more effort to do it in Ggplot, and other things are just much easier to do in Ggplot. And so, I'm sorry to make you learn both, but I think it's worth it. All right, so what we've been doing is if you want to study the relationship between some y and an x, I said go study the conditional distribution. So you can go find means as an example, or medians. How would you create a visual display from that? Well, we could just create a bar chart summarizing these conditional means. So we found these with dplyr, but this is the way we would do it with base R. So I want to walk you through the syntax. Remember, the employee data frame has a bunch of variables in it. So in base R, you would have to specify the data frame every time you refer to the variable. Now, there's a couple ways that you can avoid having to specify, employee dollar salary, employee dollar training level, employee dollar, gender, whatever. And one of the ways is the with command. So I kind of like the with command. So you say with employee, then I'm going to type in some command. So here's my command, and within that command, any variable that gets mentioned is, it looks in this data frame for that variable first. And so I don't have to type employee dollar every time I reference a variable name. So that's kind of nice. I'll just mention verbally another way to handle this. You can attach, so the command in R is attach the employee data frame to the search path. And then when R encounters something like salary or train lev, it goes through all the different folders that are in that search path, and one of the folders, if you will, is this data frame employee, and it would find it that way. All right, we're going to use the bar plot, and ordinarily bar plots, compute the percentage of cases and show that. We don't want that. We want to show the means. So the way you would do find the mean of salary for different training levels using only base R, not dplyr, is with a command called tapply. So this means apply the mean function to find the mean salary broken out by training level. So that's an alternative to the dplyr or the SQL that I showed you earlier. It's probably worth knowing. R and S have about a half a dozen different apply functions in addition to tapply. There's sapply and lapply and all these that I have a hard time keeping straight. That's why I kind of like dplyr. It's probably why Hadley Wickham developed dplyr. But this works. How would I do this in Ggplot? Well, this is one of those instances where the Ggplot code is substantially longer. So this is exactly the code that I gave you earlier. So we're going to first set up a data frame that's ready to go for Ggplot. So find the mean of salary broken out by training level. That's what those first two lines mean. Now I can pipe this directly into Ggplot. Now within Ggplot, When I specify the aesthetic, I list the X variable. So I have training level on the X-axis, therefore I list training level first. And then this mean is referring to this variable that I've computed in my dplyr command. So this is basically saying plot mean against training level. Okay, well, what sort of plot do I want to use? I'm going to use a bar plot. And then the stat equal to identity means just plot the identity function of this y. I'm not going to compute anything with it. I'm just going to, do all my computations in dplyr, and then we're just going to plot those numbers here. And so you get exactly the same plot as you did in BaseR. Just mention a few things. Xlab and ylab are some commands that will allow me to specify more user-friendly labels for my x and y axis. I could have done that with the bar plot command with the same commands, xlab and ylab, and you just specify those as options. All right, so the way I like to think about what we've done so far is I've summarized the conditional distribution of salary broken out by training level with the highest level of summary, which is a single number mean. All right, I could have done medians if I wanted, but it's a very high-level summary. Alternatively, we can do box plots. So how do I do a box plot in BaseR? Well, there's a single command, and it is real easy. So this is also the first time you've encountered the formula notation. This says show salary as a function of training level and use the employee data frame. So you're going to see this notation, the formula notation with the data frame, many, many times in R. So when we get to regression, you're going to see it with t-test, with var test. All of those other functions are going to use formula notations like this. And what we can see here is that the box plots provide I think a much more complete picture of these distributions. So those with high training almost universally have much higher salaries. So the dispersion is very small. If you have low salary, there's great dispersion in your salary. Some with low training have very high salaries. Some with low training have very low salaries. How would I do this in Ggplot? Well, Ggplot is almost as easy. I'll just give it the data frame, specify my two variables that I care about. So training level is my x, if you will, salary is the y, and then there's a function geom boxplot that gives us the box plots. And we get to see the same thing. All right. Now I'm going to move on to summarizing the dependence of some numeric variable on two categorical variables. So the two categorical variables are in this this lecture will be female and training level. And so what I'm showing in this plot is the average salary for all combinations of training level and gender. And I think the BaseR function is extremely simple and easy to use. There's a command called interaction plot. So the way interaction plot works is you're going to plot training level on the x-axis. So the first argument is the x-axis. The second argument is called the trace factor. So female is the we're going to break out different lines by that. And then the third argument is the dependent variable on the y-axis. I like to increase the visual contrast of my lines, and I do that with the color command. So color equals 1, 2 means the first line should be black, the second one should be red. And so what you'll see here is that it doesn't matter what gender you are. If you have high training, you make a high salary. However, if you have low training level, you don't want to be female because the average salary is much lower than for men. Medium level training is somewhere in between. How would we do this in Ggplot? Well, it's kind of similar to what we had before. I'm going to use a dplyr command to compute the mean salary by both training and gender. We'll send that to Ggplot. And there's an additional argument here. I want to encode gender with color. Then we'll use the line command to show the different lines defined by gender. And I'm going to throw on points as well. I really didn't need the points given the lines, but we can just add that as well. And then let's give ourselves a meaningful y-axis variable, which is mean salary. All right, cool. How would we add additional, detail to this plot? Well, we could make box plots. Instead of just showing the mean, why don't we show the 5-number summary instead? So this is the base R version, which is extremely simple. We just put a star in here. This says cross training level with female as the X variable. The problem is the plot looks really bad. We don't get labels for everything. This is low training for male. This is low training for female. So these 3 box plots are for females. These are for males, but it's not very well labeled. For some reason, this turned blue on me. Sorry about that when I was highlighting some other stuff. I think the Ggplot version is much easier. So here we're going to use a facet command to create separate plots for male and female, and then we show our 3 training levels for each of those each of the gender values. So I think Ggplot is much easier, and this introduces something that's extremely powerful, which is this whole idea of faceting, where you create separate plots for different values of this variable. All right, that's about it for my my lecture on bivariate statistics.